So let's get started with lab 9. We have one more lab to go and then we will be done. Okay. So before I start, let me just give you a small recap on what we are doing today. So we will be doing similar to your lab 8, but this time you will have two sample hypothesis testing. Okay, so when I say two sample, what are they? They are independent sample. That means the sample size will be different. Well, we are not worried about this today, but we have one more, that is dependent sample. Okay, when I say dependent sample, that means sample size is same. Or if you have any paired data, example like after, before, after, or it could be wife and husband, okay, like birth and death, something like that. So if you have these kind of samples or data, that belongs to your dependent sample. Now, as I said we have two types of sample, and we will have two procedures to perform hypothesis testing. Okay, now I don't want to go much detail into that. So in this lab we will be doing parallel plot, because we have a quantitative and qualitative both kind of data. So we will get parallel plot or parallel box plot, to be specific, parallel box plot. And example, we will have variables like salary and size. Okay, and we are going to do test for mean like we did in the previous lab, but there is one small change this time. So when you did chapter 8, you were comparing your null hypothesis. You used to compare your null hypothesis, like, say, this is how you used to write. Let's say we are doing for proportion, then you used to write like this, right? 50% or something, some value, right? Now, when you have two samples, you are supposed to compare one sample with another. You're not comparing with the hypothesis value. So in lab 9, you will not have such values called as hypothesis value. Okay, all you have to do is, this is lab 8. That is when you have one sample. So when you have two samples, H naught, your P equal to 0. I will tell you why. Okay, we will take P equal to 0 when you have two samples, and that too when you have dependent samples, the null hypothesis is always 0, because the sample size is same and the mean value or the proportion, whichever you take, is assumed to be same. So when you subtract those values from two samples, it will be 0. Okay, so the null hypothesis which I wrote now, it was supposed to be like this. Now Let's say P1 is the proportion of first sample and P2 is the proportion of second sample. Okay, and let's assume that P1 is greater than P2. Now, when you have a dependent sample, as I said you, sample size is same. So we assume that the proportion will also be same, right? So that means P1 equal to P2. That's our assumption. Now, if I want to bring this P1, P2 to the other side, okay, let me take this to the other side. It becomes negative because this side it is positive. Now, when I subtract P2 on either side, this goes to 0, right? Now, I told you that P1 and P2 are same. So I will go ahead and put this as P instead of P1, P2 because both are same, right? I'll just change the notation to P. So this is how we get the null hypothesis. Okay, that's a small derivation. So now, whenever you write your null hypothesis or alternative hypothesis in this lab, we do this, rewriting. So what do you rewrite? You will rewrite only the alternative hypothesis. Alternative hypothesis only. Okay. So what are you doing here? Now, for example, let's say your H1 is something like this. I'll take it as P1, P1 greater than P2. We have two proportions, P1, P2. Okay, and I will take it as, so P1 is greater than P2. Okay, now when you do rewriting, you have to do this for all the problems which you are doing today. When you are rewriting, your alternative hypothesis looks like this. P1 minus P2 because I'm just bringing the P2 to the other side. Now, when I bring P2 to the other side, what do you think will change? So I know that P1 will come to this side, so this becomes 0. The left part is P1 minus P2. The right part is P2 minus P2, which is 0, right? Now, what do you think will become to the sign? This is what given in the question. So example, the proportion of one sample is greater than proportion of the second sample. That's your question. And this is how I can write the null hypothesis. Now I'm going to rewrite it. So what do you mean by rewriting? I'm just bringing the P2 from the right to the left, making it one group. So this side becomes 0. But my question is, what happens to the sign? Any idea? Yes, it flips. So this is, let's say, like a rule of algebra, linear algebra. So whenever you are subtracting on either side, or else whenever you are changing the signs, you are going to change this inequality. Okay, we call this less than, greater than, not equal to, all these kinds of symbol together as inequality. Okay, so whenever you are subtracting or changing the signs, I mean positive to negative, you're going to flip the inequality. Got it? That is what we mean by rewriting here. Now, why do we have to do that? That's because, so whenever you tell JMP to calculate the p-value, it will assume that this is the claim. Okay, because we, as you can observe in chapter 8, this is how we followed, right? Now it doesn't know that we are going to flip the sign, right? So we are going to rewrite it because JMP doesn't know what we are doing. Fine. So, and that is why we flip the sign. Now once you flip the sign, you are going to choose the p-value whichever has this symbol, this inequality. Okay, for example, if you are in your diagram or in the figure, if you have prob less than t, then you are going to pick this as p-value. If you have prob e greater than t, this is wrong. You're not going to pick this p-value. Even though the claim is greater than, you're not going to pick this p-value. Fine. You have to concentrate always on the rewriting part. Right? Okay. So this is what I wanted to tell you. So enough of the lecture. Now let's go to the lab. Chapter 9. Okay, I'll straight go to the assignment part. So this assignment is easy. Now I mean this literally because we have one question. The last two labs I was telling you that it is easy, but it was too long. So this is really very easy. So we have only one part. You're going to test the claim, that is you're going to test the mean. We do not have a proportion. So I will show you for one question as usual, and you will be doing for rest of the three. Now this part you have already done in lab 8. Okay, you're going to write your null and alternative hypothesis, and one extra step is that you are going to rewrite it. Okay, you have to write the null and alternative hypothesis first, and then you're going to rewrite it, and then you're going to paste the graph which has a p-value. You're going to mention the p-value below that. You're going to compare with alpha, make your initial conclusion and final conclusion. Got it? Okay, so let's get started. Okay, so just a small information. We have a template here. This is accessible only for the 212 lab section. So if you are from another section, you can always email me and I can send you the document. So here we have a template, and we are doing assignment 9. So this is the first problem. I guess the problem has not changed. So this is a small, this is the first problem which I did, and you can follow the steps here if you do not want to watch the video. Okay, so I will just go through this. Now this is the first question. You will be writing your null and alternative hypothesis. Now just read the question for 1 minute. So we are going to test the claim that the mean salary for male. So here you can see that there are two variables involved, that is salary and sex. So we are going to compare the male's salary, and the claim is that this salary is greater than the mean salary for females. So you can easily write that your alternative hypothesis is mu1 greater than mu2. Now, what do we mean by mu? When I say hem HU, mu, so this symbol which I highlighted here is called as mu. So that we use to denote the population mean. Okay, not the sample mean. We use this symbol to denote the population mean. Okay, so if you do not know how to do this in Word file, I will try to do it. But if that is not working, that's okay. You can just type it as mu. Fine. So mu1 in the sense the mean salary for males. Mu2 means the mean salary for females. Okay, that's the definition of this notations. Now null hypothesis will always be like this. No matter what is the question, when you have two samples, this is how you will write the null hypothesis for two dependent samples. Fine. Now alternative hypothesis depends on the problem. If there is a greater word in the question, you will say mu1 greater than mu2. Okay, now once you do this, next part is to do the rewriting. Okay, now you can compare these two. The null hypothesis here and here are same. Only difference is that I'm just moving this mu2 to the left side and making the right 0. Okay, always again, no matter what is the question, this will be your null hypothesis. Okay, now when it comes to alternative hypothesis, you will do the same thing, but only change is that you're going to flip the sign. Got it? No confusion? Good. Sorry, I didn't get you. Yeah, sure. Okay, so this is your alternative hypothesis. You know how to write this, right? You know? Okay. So once you know this, when it comes to rewriting part, you are going to put this, the right part, whatever you have, you're just going to put that to the right side. Okay, you have one here, 2 here. I'm just putting this 2 to the other side. So when you are putting this back here, this is positive. When it comes to the other side, it becomes negative. Okay, so you will be writing in this way. Mu1, 2. 1 minus 2 equal to 0. I mean, mu1 minus mu2 equal to 0. Okay, so when it comes to alternative hypothesis, the left part has to be same for both null and alternative, no matter what is the question. So this null and alternative hypothesis, the left part has to be same. Only change is in the right part, that too in the inequality sign. Okay, in your question, if it is greater than, here you will be writing it as less than. Got it? That's it. Do you want me to repeat? I can still see some confusions in your face. Okay, I'll repeat. So just do not get confused. Only thing you have to change, when you have greater word in the question, you're just going to put less than sign. Reverse the sign. Got it? Really? Really? Okay, let's see. Okay, so let's go to the Word file. Just copy the first question here, and you know how to write the format. So write your name, section, date. Sandwich 9. So use this here, first part. Okay, so what are we doing? We are just going to write the null hypothesis. Now, I will just leave this to you because you know how to write it. So null hypothesis, H naught, and write the null hypothesis. Okay, and then you write alternative hypothesis, H1, so once you write your null and alternative hypothesis, all you have to do is rewrite. Again, null and alternative hypothesis, I will just write it as H naught, okay, and then H1. Okay, and if you want, if you like to use the symbol, you have a insert option in the Word file. Insert, go to insert, and to your right corner on the top, you have symbol. Okay, and you have a small arrow there next to the symbol. Click on that, and you will have mu symbol in the third row called as micro sign, if you like to do that, or else you can just type it as MHU. That's fine. Okay, if you like to use this, you can do this. Okay, so here mu1 is always equal to mu2. Mu2. Now, what will be your alternative hypothesis before rewriting? Is not equal. No, you have to follow the question first. Not equal. I guess you have this symbol also. Let's see. Yeah, you have not equal to symbol also. If you would like to use the symbol, you can. Okay, so once you write this, all you have to do is rewrite the null and alternative hypothesis again. So observe this, you can easily write. Now I'm just going to copy the same thing here. So null hypothesis, same thing. Okay, I will show you what is the change. So mu1 is not equal to mu2. That's according to the question. I will write it here. Okay, got it. Now all you have to do is change this equal to sign to negative always to all the question, and then put that equal to 0. Okay, again you will do the same thing here. Change whatever symbol you have in between mu and mu2, just delete that and put that or replace that with negative always. Okay, now on the other side you will have 0. Okay, now your work is to identify this symbol. Now I know that in the question it says not equal to. I agree with this. Now I told you that whatever you have, you just have to flip the sign, right? Now you're not going to flip the sign to this problem. Do you know why? Guess. Yeah. So alternative hypothesis cannot be equal. Okay? It can never be equal. So you have to maintain the same symbol. Okay, this is how you write the null and alternative hypothesis. So now rewriting is done. This is the confusing part. So we are done with this. Now whatever you do is just the repetition of lab 8. Okay, so once you are done with this, just give you a minute to write. I guess student in WebEx, I guess you do not have any questions. If you have, you can unmute and then speak. Okay. So you have opened your JMP. Now again, open subset of small town. If you do not have one, then you are going to download it from the Blackboard. If you have, that's fine. If you do not have, you can just do this step, or you can just skip it. Okay, now let us go back to the question. So the question is between salary and sex. So we have two variables and we are going to plot the parallel box plot. Okay, now to do that, you are going to click on analyze. So since we have two different types, we are going to do fit y by x, fit y by x. Now here, put your salary variable in the y response and sex in the x factor. So analyze fit y by x, salary in the x y response and sex in the x factor. Click on OK. You will get a parallel plot. So we need a parallel box plot. So you are going to click on the red arrow here and then go to display option. Red arrow, display option. It will be in the bottom. You didn't get it? You got it? Okay. So once you get the display option, just click on the box plot. Click on the box plot. Done. So this is your parallel box plot. Now all you need is the p-value. So click on the red arrow again. So whenever you are testing for mean, you are going to do t-test, right? You are going to find t alpha by 2, not z-score. So you have to click on t-test here. Click on t-test. Done. Now you can see here, you can see in the bottom you have okay. So in the bottom you have three values. So your question is which value you have to pick, right? You have probability greater than modulus of t. So the two straight lines between the t. So that we call it as modulus or absolute. Okay. So and then we have probability greater than t, probability less than t. All these three values are your p-value. Okay. So your decision depends on this alternative hypothesis rewrite. Okay, you have to concentrate on this. So this is the main thing you need always. Now I know that there is a not equal to symbol. Now you have done this in your lab 8. So now tell me which value should I use? Is it 1, 2 or 3? 1, right? Because we have absolute sign there. Got it? So now we got the p-value. So yeah, you have to copy this and okay, sure. They want me to show the graph again. So I'm just repeating the step. So you have to go to analyze fit y by x, analyze fit y by x. Okay. Now we have two variables, salary and sex. So you are going to put the salary variable in the y response and sex variable in the x factor. Then click on OK. you will get a parallel plot. Okay, so once you get this, click on the red arrow here and go to display option. So it will be in the bottom, I think bottom 3 or something. So go to display option and then you have to click on the box plot. Display option, box plot. Okay, so once you do this, you will get the red box. So, and then you are going back to the red arrow again and click on the t-test. Okay, click on t-test, you will get this graph. Done. So once you are done with this, you are just going to choose the p-value. And one more step is you are going to plot the QQ plot. Okay, you have to click on the red arrow and then you're going to paste the whole thing in your Word file. Just delete whatever you have done. Okay, you're going to the plot you have already pasted. You did, okay, you did in the Word file. Okay, you have to add this as well. So go to the red arrow and click on normal quantile plot. So we will do, we need line of fit, but so give me a minute. Let's see whether you have to do or not. We do not have n value to compare, so we need this. Yeah, we do not have n value. Now, let me do this again. Analyze fit y by x. You have already done this, so do not repeat. To red arrow, display option, box plot, and then t-test. So once you are done till here, you are done till here, right? So you just have to add one more step, that is go back to the red arrow and go to normal quantile plot. Normal quantile plot, we need a QQ plot. So you can choose any two option, that's fine. So I will go with the first option, click on this and you get a normality graph. Done. So what does this mean? That means this is your data points. The curve, the red one is for female and the blue one is for male. How do I know that? It's given here. Okay, the red is for female, blue is for male. Fine. And the two lines which you see here, the straight lines, are your line of fit or regression line. So this data points should satisfy this line. Now, why am I doing this? It's only because you are going to check the validity of test, right? Like you did in the lab 8. So in lab 8, we used to compare the n value, n greater than 30 or so on. So, but this time we do not have n value given here. So we are going to do a normal quantile plot. So if this is normally distributed, that means this line which you see here, the gray one, that has to give you a straight line. If it is following a straight line, we say it is normally distributed and the test is valid. If not, the test is not valid. Got it? Done? Okay. Now, once you do this, you are going to copy the whole thing. Just copy this and paste it in your Word file. You can change this to picture format and minimize. Done. So once you are done with this, you will write your p-value. p-value equal to, so it is not equal to, so it is 0.3014, and your alpha will be equal to 0.05. It is given in the question, so alpha is 0.05. Now here you can see that p is greater than alpha. Okay. So we did this, we did till here, the value is done. I'll just copy the same thing here. Make it as blue. Yeah. So once you get your p-value, you are going to compare that with alpha like you did in lab 8. So since it is greater than, we say fail to reject H0, the null hypothesis, and then you write your plain English conclusion or the final conclusion. So this depends on the chart which I showed you in the last lab. Okay, so if you have this kind of decision and the claim is H1, then you say there is not enough evidence to support the claim, and then followed by the claim here. So this is equal to, it's not equal to. Done. And then you will check the normality. I will leave that to you. If it is normal, you can say check for normality. If normal, if normally distributed. Oh, yes. So if you are done with the first part, you can go ahead and do the second question here. So your second question is, okay. So your second question is test the claim that the mean BMI is greater than BMI for females. Okay, all you have to change is the sign of alternative hypothesis and repeat the procedure. Okay, and I guess that's it. So That will complete your lab 9. All you have to do is repeat the same procedure which I taught you for first question. Do the same thing for the rest of the problems. All you have to do is change the sign when it comes to alternative hypothesis and find the p-value, and then you will draw your QQ plot, check for normality if it is. So when I mean check for normality, that means the data points has to follow the straight line. If it is following, you say it is normal and the test is valid. So if you have completed till there, then that will end your chapter 9. Stop the recording here. Yeah, you do not have to summarize anything. So yeah, summarizing is not necessary for lab 9. Okay, so your question was the part 1C. So if you have equal to, then your alternative hypothesis will have not equal to sign. Okay, so it will, your question C will probably look similar to your question 1.
So with question A, it was asking for not equal to. C is asking for equal
Yes.
to. It would still be the
Yes.
same.
Yes, it
Sorry.
will be the same.
Okay.
Mm-hmm.
Thank you.
No problem.